Hello everyone, welcome to Magnetized Labs. This is your go-to destination for all electronics and circuit design. This is our very first video. Here our mission is to guide electronic enthusiasts like you step by step from the very basics to mastering advanced design concepts. Whether you are just starting out or looking to deepen your understanding, we will dive deep into the core principles and design techniques to help you build a strong foundation. Now let's jump right into today's video. Design of BTL audio 100-watt power amplifier using TPA3116 in KiCAD. So we have to understand the topic first. What is BTL and what is TPA3116 does? This is single-ended amplifier. So as everyone knows, this is a basic circuit of amplifier diagram. This is an op-amp circuit, and this circuit is called non-inverting amplifier. So whatever the input you are giving at the analog input side, you will get the amplified output according to your feedback resistor and your gain setting. Here 1 plus R divided by Rin is called gain factor. According to this thing, you will get the output voltage in the ratio of V in. So you assume that you are giving one voltage here and you will get a voltage called V out. So that depends on your gain setting factor. So you assume that you are putting a 0 ohm resistor here, so it will be a short, and Rin you can consider 1k or 100 ohm, whatever according to your need. So you will get one voltage here. This will act as a voltage follower. Then you will get one voltage output here with respect to ground. So this is the speaker load. So this is the single-ended load type. So you will get one voltage across the speaker. This is how the basic circuit of operational amplifier will work. BTL. What is BTL? BTL means bridge tied load. So two outputs of the operational amplifier will be tied to one load, that is called speaker. So this speaker load here, it is called bridge tied load. Here you can give differential input, analog input plus and analog input minus. You will give 1 voltage here, you will get 1 voltage output here. You will give minus 1 voltage here, you will get minus 1 voltage output here. So in such case, across this load, you will get minus 1 here plus 1 here, so totally 2 voltage. So this is how BTL amplifier will work. It will double the voltage and you will get the more power output compared to single-ended amplifier. Even if you want, you can increase your amplification factor as a gain factor. You will get more output. You can keep 10 as your gain factor, so you will get output as 10 times of V. What is PBTL? Parallel bridge tied load. Four operational amplifiers are used here and they are tied together. Positive sides and negative sides are tied together and given to the load. Here you are giving 1 voltage input here and you will get 1 voltage output here. Same way goes for right input plus 1 voltage and 1 voltage output here. You will get the voltage is equal to 1 here. But in the negative ways, same you will get minus 1 voltage here, so minus 1 here plus 1, totally 2 voltage across the load. But the thing is, current from this and this will be added together and it will be given to the load, so you will get more current driven capability according to your speaker. This is how we will get more output from PBTL than BTL. This is our black diagram of the project. First, we will get the analog input from 3.5 mm audio jack. Then we will convert that single-ended signal to differential signal. We will give it to audio amplifier IC. Power supply we are using here 12 to 24 volt input. This will be capable of taking. We can give 24 to get the maximum output. And after that, amplifier IC's output is going to the filter circuit. Then directly we are feeding it to the speakers. We'll go to the schematic now. This is our schematic. Here this is audio amplifier IC. I will explain pin by pin. And then here power decoupling, we will take 24 volt input and power decoupling capacitors with one indicator LED. 3.5 mm audio jack for getting analog input. Here I am taking this analog input to this operational amplifier to convert single-ender to differential signals. If you don't want to convert single-ender to differential signals, you can directly feed that left input here, positive and negative, you can give it to ground. You will get half of the output. You will not be able to get the total output power of the amplifier IC, but it will also work. Yes, so I'll explain pin by pin. Mode select pin. What is mode select pin? We'll go to datasheet and we'll understand it better. This is the datasheet of TPA3116D2 and it is a class D amplifier mode selection input. Low means BD mode, high means 1 SPW mode. What is BD mode and what is 1 SPW mode? BD mode means bridge differential modulated method. 1 SPW means single-sided pulse width modulation method. Here BD modulation means they will keep the duty cycle is fixed 50% in ideal mode and the output of the audio amplifier switches will switch in opposite phases. Here, because of its fixed frequency and it is differential PWM signals, your EMI will be very less and efficiency also will be better. And in single-sided pulse width modulated method, they will keep the one side of the load static and the other side they will switch with the modulated PWM signal. According to the reference whatever I have read, BD modulation is more efficient and it is EMI tolerant. So we can go for BD mode method. So I gave this modulation select pin to ground. Next pin is shutdown pin. Shutdown logic input for audio amplifier. Low means output high impedance state. High input means output will be enabled. So shutdown state I can give it to directly V in. So this pin is capable of handling till the level of V in voltage. So I give directly pull up to V in and with 100k resistor. This is fault pin. I have tied this fault pin to SDZ shutdown pin. I will say why it is. First we will understand what is fault pin. Fault pin is an open collector output which will be driven low when any faults detected by the IC. Overcurrent protection or hiccup mode protection or thermal shutdown anything occurred. So this pin will be driven low. Automatically this pin will drive this shutdown pin also low. So the IC will go in shutdown mode. Whenever the fault recovers, this pin automatically will drive the open collector's high impedance state and then this will be enabled. Next, right input positive and right input negative. I have kept 10 microfarad AC coupling capacitor. I will say why it is. Then we will go for PLIMIT pin. Yes, this TPA3116D2 family has a built-in voltage limiter that can be used to limit the output voltage level below the supply head. There is a P-limit operation when it is going above the threshold level, so it will automatically flip the voltage. We are using 24 voltage input, so the P-limit voltage they have set is GVDD or to ground. So the P-limit pin we don't need to connect to ground with any resistor, but we have to short with GVDD. So that we have done here. Yes, so it will clip the output voltage of 17.9 voltage RMS. Next GVDD pin. This pin is the internal voltage supply for the gate drivers of the off-bridge circuit in the class D amplifier. And then next gain select pin. So we are not using any master slave architecture, so we will go for master architecture. We will choose the maximum gain, so we will get the more output power and more sound. So for that we have to give one resistor to ground 47 ohm we have given and one more resistor to GVDD 75 kilo ohm. Yeah, that also we have done. And then in such case input impedance will be 9 kilo ohm. So come here down to the page. Gain we have used 36 decibel with the input impedance of 9 kilo ohm. In such case we have to use 10 microfarad input AC coupling capacitors because we have selected the maximum gain out of it So it will amplify the maximum possible. If you are giving a little bit input of noise also, that will amplify more, so you will get distorted output. So to eliminate that, we have to use a bigger AC coupling capacitors. So this will act as a high pass filter with a cutoff frequency of 1.8 Hz. Next pin is ground pin. We have connected it to ground. Same goes for left input positive and right input positive. And this is a mute pin. Mute pin, the threshold voltages are here. Mute pin minimum high input threshold is 2 volt. You have to give 2 or more voltage to trigger mute. We are not using anywhere here mute button. So to disable this thing, low level input voltage for mute, you have to give less than 0.8 voltage. So I have connected it to ground through 100k. So AM2, AM1 and AM0 for avoiding the AM band frequency interference. We are not using that here. So I have connected all these 3 pins to ground as per the datasheet recommendation. Next, these are all the power stage side. So top and bottom they have given uh, 2 pins each for power input. I have connected decoupling capacitor as per the datasheet recommendation, 220 microfarad electrolytic capacitor with low ASR, and then few ceramic capacitor for more efficient power decoupling. Same here. And these are all the bootstrap capacitors for the high side gate driver circuit, and then here are the filter circuit as per the datasheet recommendation, 10 microhenry and 68 nanofarad. They have recommended if you are using BTL load, you can use output filter L equal to 10 microhenry, C is equal to 68 nanofarad in 4 ohm and 8 ohm speaker, both speaker you can use. Yes, these are all the snubber provision to avoid the speaker damage when it goes the above rated voltage. Yeah, so here I am using 7812 to convert 24 to 12 volt, so that I can use this 12 volt for reference signal to this operational amplifier, also to power this operational amplifier as well. This I am using for converting single under to differential signal, as I said before. Yes. Then for input and output connectors, I am using keystone red bind post connectors. Also all the components whichever I have chosen here all are automotive grade. So I have kept the connector also in a sturdy way. So I am using this for power input also and speaker output as well. These are all the mounting holes for PCB. Yeah, now we can go to PCB. This is how PCB will look. So I will explain the placements. So if you place the components very properly, that is equal to half PCB done. So here I have kept the input connectors. I have kept the label to understand what this connector does, and then ground pin connection here for the connector, and audio input. I am using 3.5 mm jack. So I am taking the audio signal from here. I have delay tuned so that both the signal will reach at a time, and indicator LED is here, and 7812 for supplying the operational amplifier and to use the reference signal as well. These operational amplifiers are for converting single ender to differential signals, as I said before, and these are all the peripheral capacitors and resistors, power decoupling capacitors on the both sides, and then these are all the bootstrap capacitors and inductive and capacitive filters. Here are the right output terminal blocks and left output terminal blocks, and then I have kept a small reference box so that I will not keep the component inside. If I keep the component inside, I will not be able to route it properly, and it will be too congested. Also, it is very difficult to take the nearby pin outside. I have considered all the current flow calculations. I have kept the thickness of the traces as per the recommendations. So there will be no problem in thermal stability. Also I have stitched with VS for better decouplings, even power decoupling and signal decoupling. I have used the logo here, the title of the project here, and then backside very few components I have kept, and I routed it in an efficient way. Yeah, that's it about the PCB. Next we'll go for 3D. This is how the 3D will look. So input connectors, I have kept red color connector for positive so that they will be able to easily understand where to connect. They will not swap the polarity. So this IC doesn't have any reverse polarity protection, so we have to be very careful when we are connecting positive and negative inputs of power. And then these are all the output connectors, and then audio input connector for input of analog signal. And then logo here, the IC I have kept, and peripheral components, bootstrap capacitors, inductive and capacitive filters. For mounting holes are symmetric so that they will be able to make 3D enclosure without any problems. So for the same circuit, we have to generate a BoM. I'll go to the BoM. Yes, this is the BoM. So I have kept all the columns, and I recommend people to use all these columns because all are important informations, reference and quantity per PCB, MPN, APN. APN is alternative part number. That is very important because you selected one part number. If this part number goes out of stock or it is not available in online, you can choose the alternative part number, then you can put it on the same. Always keep this as an habit whenever you are designing a PCB. If you are choosing an MPN, you keep always one alternative part at least, and then do not populate. If you don't want to populate anything, you can mark here, and then value of the component, and manufacturer of the component, and then package of the footprint, and footprint name, brief description about the component, and data sheet. All the columns are very important, so you can choose this for your best BOM model format. File management. So when you are designing a PCB for one project, you can consider all these informations to keep it in one folder, because these are all the components. When you are giving this project outside, they will be able to understand it more better. Assembly documents. So this assembly document will help the person who is assembling manually. So these are all the documents will contain where the component will go and locate on the board or sit on the board. BoM. BoM I have shown. So BoM is very important for one PCB project. And then design documentations. So if you made any calculations, or if you tried some level of testing, that you can document and you can keep it in this folder. Gerber files. Gerber files are more important for PCB manufacturing, and then this will contain all the information about how the etching will be. Mechanical files. This will be used for 3D modeling. If you're designing one PCB enclosure, you can use this mechanical files. Placement files. Placement files are used for automatic assembly when you are sending the board assembly outside. Next, schematic. Schematic, you can keep it as a PDF in this folder. Stack up. So this will say how the PCB is structured and how it's going to be manufactured. This is the file folder and assembly documents. I have kept top and bottom assembly as a PDF, and then BOM folder. Inside BOM file is there. Design documentation. You can keep block diagram, datasheet, or if you made any PPT, you can keep here. Gerber files. So you can keep the Gerber files inside it, and mechanical files. Step file will be there, and then placement files. As I said, this will be used for automatic placements if you are sending the assembly outside. So this will have the reference of the component and value, package, position x and y coordinates. This position and x y coordinates will be used for automatic assembly in the automatic assembly machine. So here rotation is 0 degree and side top side. Same goes for bottom side also. Next, schematic. Schematic I have kept it as a PDF inside, and then stack up. So this will contain all these details. You can choose this as a standard format, and then you can use it for your future design. Board name, number of layers of the board, and then thickness of these layers, and then you can choose the standard format 1.6 mm standard, and then dimensions you can mention here. Silk screen, you can change the color if you want, also the solder mask color as well, so that also you can mention here. If you need any particular impedance control for your PCB board, that also you can mention here. In such case, if you are mentioning yes here, you have to mention all the impedance controlled traces and thickness, all these information you have to give down. delivery days you can mention how many the days you want, and the number of PCBs. The finish of the PCB, I always go for any finish, electroless, nickel immersion gold plating. You can verify your Gerbers using a software called Viewmate. You can go and you can import all your generated Gerbers here, and you will be able to turn on and turn off each layers separately, so that you will be able to check whether you have designed properly or not. Here you can just disable everything, just enable everything, like that it will work, and you can turn on and turn off each and every layer individually. Yes, you can see here. Yeah, this is how it will work. This is a useful software. You can use it for verification of your Gerbers. That is it. That is it. This is how we have to design one PCB from the scratch. This is the recommended activity, and if you have any doubts you can mention in the comment section. I will reply for that. And yeah, we will meet in the next project. Thank you.